Oh, after the week I'm having, we need all the likes and subscribes that we can get in the world. In today's video, we're going to be looking at some firewall tasks. Configuring a firewall, basics. Let's get into the lab. Welcome to the lab. In today's lab, we've got our task list to complete. Configuring this Palo Alto firewall. We need to provide internet access to our two internal VLANs. We need to secure traffic from our desktop VLANs to one of our server nodes sitting in VLAN 100. We need to secure traffic from our servers to our DMZ server. And we need to allow our public internet to be able to access the web server of this device in our DMZ. So let's start by jumping onto the firewall. Welcome to the Palo Alto Firewall. So our first task, if we have a look, is to configure internet access for VLAN 100 and 101. So we're going to start by configuring this trunk interface towards the firewall and giving it a gateway address for our devices to speak to. So we're going to jump over to this network tab and let's have a quick check. It's E1/2. So here's our interface E1/2. We're going to give that a layer 3. And we're going to create a subinterface. We're going to start with 100. And we're going to tag it as 100. It's going to be part of our default routing instance. We're not going to be doing any VRFs. 100 was the server zone. So we'll call this the server zone. And we'll give an IP address of 192.168.100.254. So it will be the gateway. And for a management profile, we will just allow ping. That's our first interface. Let's create one for the desktop subnet or VLAN 101. And we'll give it the same subnet address 101. And we'll give it 254 for its IP address. So add a subinterface. Subinterface 101. We will tag it as 101. It's part of our default routing. And we will create a security zone of desktop. We will assign an IP 192.168.101.254/24. And again, we will give it the ping only. So that's our sub-interfaces going down here. Whilst we're at it and configuring interfaces, we might as well configure the DMZ interface. So its zone is on 1/3 and it's got an IP address of 50.0. So here 1/3, except this one, we're using the whole interface. We're not creating sub-interfaces. So we will just assign a new security zone straight onto the interface. We'll configure an IP address of 192.168.50.254/24. And again, they only need to be able to ping that interface for testing purposes. So we've configured 3 interfaces, E1/3 towards our DMZ, our 2 internal interfaces. Now we'll configure the interface towards the internet. So E1/1. So this is going to be our outside interface. So again, it's going to be a layer 3 interface. It's going to be part of our default routing. We're going to give it another security zone. We'll call this one outside. So we're well aware that this is outside of our domain. And our public IP allocation is 203.0.113.2/26. Next, we'll create our default route for that interface. So we're going to jump to our virtual routers. Under default here, we will add a static route. We'll call it default. And that's going to be 0.0.0.0/0. That's going to be going out of E1/1. And its hop address is going to be 203.0.113.1. So we've got a default route to our upstream. We've got our interfaces configured and our security zones configured. Next, we'll configure our outbound NAT. So we'll call this our outbound NAT. And so the original packet will be coming from our server subnet and our desktop subnet. It will be going to the outside interface, and it will be coming with a source address of 192.168.101.0/24 or 192.168.100.0/24. And then we're going to translate that to the IP address of the interface on the outside. We'll click on OK. So I think we're ready to commit. Nope. Let's create a policy. So next we jump into the security section and we'll create an internet policy. So we'll call this the internet. And the same again, the source will be coming from our desktop zone and our server zone. We have an IP address of 192.168.100.0/24 and 192.168.101.0/24. The destination again will be outside. It will be any address. And for now, we'll just allow any application. And we'll hit commit. So what have we done? To configure internet access, we've had to configure an IP address on the trunk link towards the switch for both VLANs 100 and 101. We've had to set up our outside interface towards the ISP. And we've had to set up our NAT, outbound NAT, and we've had to set our default route towards the ISP gateway. And in the meantime, we've also configured the IP address of the gateway interface for our DMZ zone. So all of our machines should now be able to, at a minimum, ping their gateway interfaces. So if we jump onto server 1, and we ping 192.168.100.254. We can see we can reach the firewall. We won't be able to reach anything else because we haven't assigned any policies to allow that to happen. But we should now be able to reach that internet www server, which was running on 203.0.113.66. And we can. So now our internal devices have internet access via this rule. And we can see there that hits are increasing. We have a look at the monitor. We can see traffic. Our outbound server is being allowed access to the internet. So now that our two internal subnets have internet access, our next task is configure our DMZ zone to only allow it to be able to ping the public public web server. That is all it should be able to do and nothing else. So let's jump back over and create a rule for that. So we don't want to add it to this policy because this policy is allowed to access everything on the internet. So we're going to add a separate policy. So we'll add one and we'll call it DMZ internet. and its source is going to be from the DMZ zone with an address of 192.168.50.0/24. So we allow the DMZ subnet to have access to outside, and we only want it to be able to access this server, nothing else. So we're going to allow it to 203.0.113.66. So instead of any, it's going to go to 203.0.113.66. And the application we said we wanted was ping. And we'll hit on OK. We'll place this one before the internet rule. We'll hit commit on that. And even though we've added a policy, there's still one more rule we need to add, or another policy we need to add, and that is we need to change our outbound NAT policy to include the DMZ location. So under the original packet, I'm going to change this to include the DMZ zone and the DMZ zone subnet of 192.168.50.0/24. Now we could add this as just a blanket 192.168.0.0 to include, but we're going to include the individual ones just to show how you can add and be specific. So we're going to commit that rule. And then once that's committed, we've got our NAT rule updated to allow the DMZ zone. We've configured the policy to allow the DMZ zone to only access this server and to only ping. Obviously, it's not very useful, but it's for demonstration purposes. So once this is committed, so one thing with Palo Alto, it takes a very long time for commits to go through. Even on genuine hardware running in a data center, I find that whenever I do a commit, it takes a very long time to do a commit. Yeah, any other device on the Cisco Nexus, you hit save, it's saved. Right, so that's updated. So now if we jump onto our server 1 in our DMZ zone, I think this is the one, IP address. 50.1, yes. So this one, we should now be able to ping that public box. And we can. But if I try and SSH into that address, it should time out because we are only allowing ping. And there we go. We can see it doesn't work. And if I now quickly come back over to the policies section, and under this default rule here, if I override and I turn on a logging, when I now try and access that server, we will see under the monitoring section, the denies coming through. So if I try and SSH again to that server, and I come back to the monitoring tab and I refresh, and we have a look, we'll see here from the DMZ to the outside, from this IP address to this IP to port 22, denied. And there we go. We can see that we are blocking this host from accessing anything else on the internet apart from this host and ping. So our next job is something that's normally very common, is to allow access to a public facing service from the internet. So we're now going to use Destination NAT and some policies to allow this internet client to reach the web server of our server in DMZ1. So we need to start by creating our inbound DNAT, our destination NAT. So we'll call this DNAT www. The original packet is going to be from outside, to our outside interface from any source address going to our public IP address, which was 203.0.113.2. And then we're going to translate that to a static IP address of 192.168.50.1 and the port 80. So what we're doing here is we're saying that if anything coming from the outside zone to the outside zone of this public IP address of this port, we're going to translate it to this server port 80. Now, if we come over to our security rules, we will add a rule and say public www. The source will be outside with any address, and the destination will be to our DMZ. But the destination host we put in will be our public one, 203.0.113.2. And the application would be port 80, which is HTTP. Well, I think under here we can do it as web browsing. Application web browsing, port 80. And we will allow that rule. I'll move that up. So what we have here is we're allowing our any address from our outside interface to our DMZ interface that's trying to access this public IP address. We're going to allow it to access port 80, because once it hits this address, we're then going to NAT it using our destination NAT and say that anything that's coming to this IP address on port 80 is going to come into the DMZ zone and access the private IP address of this server. So if I now go and jump onto this public server, and I log in on here, I will start a web browser up. This will give us a bare minimum browser, and we try to access HTTP / 203.0.113.2. We can see we get our Apache web page, which is running on this device here. So we have allowed our public internet service to come through our ISP to our firewall. We've then allowed port 80 to be translated from the public IP address to the private IP address inside this zone. And we've added a policy on our firewall which allows that to happen. And there we can see the hit count has increased, so we can see the traffic has come through. If we go here and go log viewer, we can see that from outside to the DMZ zone with a source address of 66, which is that public server, went to our public IP address on the firewall to port 80, and we natted that traffic through and allowed it via this public www rule. So we can see that we have now successfully completed our next challenge, which was to allow the internet access to the web server in the DMZ zone. So our next challenge is to allow our server zone, our server subnet, and our VLAN 100 to allow server 1 out of that zone to access the DMZ server, but to only allow it to access the FTP service that is running on here and nothing else. So server 1 needs to access server 1 in the DMZ, but only FTP. So we're going to jump back onto the firewall and we're going to create a rule. This time, because it's internal, there'll be no need for us to create any NAT rules. So we'll select there and we'll go add. And this will be server 1 to DMZ FTP. So the source is going to be coming from our server zone, and it's going to be coming from our server 1 subnet address, which was 192.168.100.1. Let's go and double check. So the IP address of this server is 100.1. Correct. Our destination is going to be the DMZ, and it can only talk to that server 192.168.50.1. And we said it can only access FTP. Obviously, we'll allow it and we'll log it. So there we can see server to DMZ FTP. The rule is added. So we will commit that and we'll go and test it. There we go. We can see we committed successfully. So let's jump over to server 1 and let's try and ping the DMZ server. We can see we can't. We know that the server is online, so we know that there's not a networking problem. The only reason why this server can't ping is because we're not allowing it. But we can FTP null 0 labs at 192 at 192.168.50.1. And we're being asked for the password. And there we go. We can see we're in. So we are able to FTP successfully from server 1 to the DMZ server via the firewall. If you notice, I didn't have to open any rules on this side to say you're allowed to go back to server 1. That's because the firewall is stateful. Because the traffic was initiated from this side to the server, the firewall knows that there has to be a return path and allows that traffic by default. So our next task is to allow server 2 to be able to SSH to the server and to be able to ping it. So it needs to be able to do 2 tasks, unlike server 1, which is only allowed to do 1 task. So again, we're going to add a rule, and we can clone this one and make some changes. So we'll clone it directly underneath, and then I'll edit it. And I'll say this is server 2 to DMZ, ping and SSH. The source address is going to be .2 for server 2 to the same zone. The applications that we're going to allow are now going to be different. We're going to allow SSH and we're going to allow ping. And if I hit OK and commit, that's the second rule added quite simply. And we'll wait for this to commit and then we'll go and test. Okay, that committed successfully. Now let's find server 2. When we click on OK, we'll log into server 2 now. And now we'll test ping 192.168.50.1. And we can see that server 2 is able to ping the DMZ server, unlike server 1. And server 2 can also SSH into server 2. And there we see it's now on a remote session on 192.168.50.1. So that's our 2 rules added for server 1 and server 2 to the DMZ. So our next task is to allow our desktop zone, where our clients are living, and allow them to only access the web server on server 2. They shouldn't be able to access anything else. So again, this is quite a simple rule. We're going to allow the zone to access this server, and only so that they can access the web server. Okay, so we jump here, we will add a rule, and we'll say desktop www s1 s2, sorry. The source will be from our desktops, and because we want to allow all of our desktops, not just one, so that'll be the subnet. And we want to allow that to the server zone, and only server 2. Not server 1. And again, we only want to allow them to access the web server. So we'll do web browsing, which will be port 80. The rest we'll leave as is and hit apply. So I should now be able to jump onto, actually no, we won't be able to, because our desktops will all require an IP address. So one thing that we can do also from our firewall is to enable DHCP services to provide IP addressing to clients. So what we're going to do is we're going to enable that so that our desktop clients can have a private IP address in the 192.168.101 zone, and then they will be able to communicate with the rest of the network. Right, now that's committed, let's set up DHCP. So if we look, we have got our desktop interface, which is on 2.101, sorry, an IP address of 101.254 is the gateway. So on there, we're now going to enable DHCP. So we're going to come into DHCP server. We're going to click on add. We're going to select that interface. We're going to say it's enabled. I'm going to say ping. And we're going to set a pool 192.168.101.10 to 192.168.101.50. That should be enough. If we wanted to reserve an IP address per MAC, we could add it on this side. We're going to set some options. The gateway address is 192.168.101.254, which is the firewall. The subnet mask is 255.255.255.0. And we will set a public DNS entry. We'll click on OK. We'll hit commit. And once that's successfully committed, when we look back at the interfaces, we should see a little symbol telling us that the DHCP service is enabled. And there we go. We can see features. DHCP server is running on the desktop interface. So now if we go and select one of our desktops, so here we are on our desktop. Now, if we go and check our network settings, and we enable, we should see it's connected. It has received an IP address of 192.168.101.10. It's received the gateway and it's received the DNS. If we double check under IPv4, we can see it's received it via DHCP. We come back to the firewall and we have a look under the view allocations. We can see under the DHCP service, we can see that the desktop was assigned an IP address. And I think if I can pull that slightly, there we go. So we can see the IP address and the MAC address that it was assigned to. So we know that's working. So if we jump over here now and open our web browser, there we go. We can see the web page running on here. And then we should also be able to reach the one on the internet because we allowed the desktops to access the internet as well. So that should be http://203.0.113.66. And there we go. We can see they've reached the Apache page running on the internet side of the firewall also. So the next type of firewall we're going to look at, now that we've done our physical firewall configurations and NATing. So the next one is these two servers. By default, because they are living in the same layer 2 zone, they can see each other, they can ping each other, they can access each other's management. They can SSH into each other in this instance because SSH is enabled on the Linux servers. So if I were to jump onto server 1 and try and SSH into null 0 labs at 192.168.100.2, we can see it asks for a password and I can connect. Now, we don't want to allow that to happen, but because they are within the same zone, there's no rule that I can put on up here to say you can't access this one or this one can't access this one. So this is where we need to rely on the firewall that exists on the server. So now to block this, we're going to use the onboard firewall. So we're going to do sudo UFW enable. And this enables the local software-based firewall. Now you can see I've added a rule to deny access to port from port 22 from server 2. So if I try and SSH there, we can see that I can no longer SSH from server 2 into SSH and SSH into server 1. As the firewall is not running on server 2 at the moment, from server 1, I can still SSH null 0 labs at 192.168.100.2. You can see I can still SSH into server 2. So what we will do now is we will do the same on this side. We will do a sudo UFW enable, and we will enable the software firewall that is running on the server. And we will then do sudo UFW for the firewall, and we will deny from 192.168.100.1 proto TCP to any port 22. And the rule is added. So now when I try and SSH from server 1 to server 2, we can see that they can no longer get access to each other's management, even though they are technically inside the same zone. So they can still access each other's services. They can still access the web service. They can still ping each other. And if we check here on the firewall status, we've added the deny to deny server 1 from accessing server 2. We've then added the rule to allow HTTP from anywhere, and we're then going to also allow the rule to allow SSH from anywhere else so that our desktop servers, desktop clients can SSH into the server later. So if we do the same, we'll do a UFW allow SSH. And now if we do a status, we'll see that we are denying from our server within the same zone. We're allowing our web server access, and we're allowing 22 for our SSH access from other resources, because again, the same as with the hardware firewall, the rules are sequential. It's going to be whichever rule hits first, that's where it stops. So because we've got the deny rule at the top, we're going to deny. So if we could allow the desktops to be able to SSH into the server if it wanted to manage it. So we could quite easily add another rule here if we cloned it. And we'll call this desktops SSH servers. And we'll allow the servers, the desktop zone, to be able to access any address inside the server zone, and we'll allow them to SSH. We'll commit that. And then once that rule goes live, that will allow our desktops to be able to SSH and manage our two servers. And I think for a bonus section after this, we'll go back and revisit our DMZ server, and we will use a different public IP address for the in and outbound NAT. So at the moment, we're using our physical interfaces IP address as our source NAT and our destination NAT. But what if you wanted to use another IP address out of your pool for one of your servers rather than using the interface address? So we will make a change and we'll test that. Over to desktop. Yes, I can SSH now. So I wasn't blocking it at the firewall level. It was being blocked at the software firewalls level, because you can see the rule is the hit counter is going up. Our desktops can now also SSH into both of our servers and access the web server service on server 2. So finally, let's deal with that changing of our destination NAT to not use our interface one. So we're back in our NAT policies section, and if we edit our NAT, we're still going to be the same, but instead of it going to this address, which is the one that's living on our interface, we'll use the next one out of our range, which is .3, and we'll translate that to the same location. So that will now translate that new public IP address to our server. We will also then update our public www rule so that, again, we're matching up with our other public IP address we have in our pool. And then what we might like to do is, instead of our public DNS server from the DMZ using this range here, we might want to add a new outbound NAT, a new source NAT. So we'll call this the DMZ or the www source NAT. And so the original packet is going to be coming from our DMZ to outside. The source address is going to be 192.168.50.1, which is our DMZ server. And we're going to translate that to an address of 203.0.1.3.3. So what it's going to do, if I put it in this order, the source NAT for the WW will come first. So 50.1 will be natted outbound to this address. Anything else within that network will get natted to the standard interface address. And then our destination NAT inbound, when they want to access our public web server, you'll now use this public IP address. So if we commit this, And obviously this goes without saying, you can only use an IP address that is within your allocation. And we now go to our .3 address. We can now see we have our web page running there. If we go to 2, we can see it's timing out. It's not able to resolve a page to the address there anymore, which is what we want. Now, if we wanted to change it so that the whole IP address was going to that zone, we would easily just remove the service and make it any. And then under the translated packet, we can also just remove that. And now we're saying from this IP address to this IP address on the outside, we're allowing anything. But now under the policy, we can now just add the rules under the policy to say which services are now available, rather than adding individual ports in here and then adding the same ports under the security policy. But again, if you're short on IP addresses, you're going to want to do it in a way where you're using the same public IP address, and then you're then just changing the port numbers and they're going to different services depending on what you're using them for. And there we go, we see it's committed successfully. If we look at our security policy, nothing's changed on our security policy. We're still allowing this IP address, but we're only allowing the web service anyway. You can see we can't ping that address, but we are NATing everything through. So technically we could select this and we could say we're going to allow ping also. Not that you'd really want to, but we could allow it. And then we can now also ping to that public IP address, and it will come through to this internal IP address, because what we're doing now is we're NATing an entire public IP address to a server. So one whole IP address, one whole server, whereas before we were doing one IP address and we're pointing one port number at an internal server and IP address. So we'll let this commit, and then we should see the ping come through. And just like that, we can see that our public web server is now responding on its public IP address to the internet host. And finally, to close this video out, we're going to do another final common task that you should do for all of your devices, which is to make sure that you have your individual users or admin users either authenticating via a radius source, and we've covered configuring radius in a previous video, or at the very least, under your administrators, change your administrator password and add an individual login for each user. So I'll add null0 labs. I will set a secure password as my user, if I can type correctly. There we go. We can now see that I am logged in as null0 labs, and now any changes that I made or make will be logged against my user account. So there you go. We've covered the basics of firewall configuration using source and destination NATs, using policies, using zones, using DHCP services, configuring rules. And next video, we'll extend this this firewall, and we will add site-to-site VPNs. So stay tuned for that one, and I will see you on the next video.